Hi everybody, this is Mr. Lee. Today we're going to go over time, speed, and velocity. Alright, now you might be asking yourself, Mr. Lee, I kind of know what time is, right? I live by it day to day. Well, let's go over this. So, time, if you were to really ask someone, what is the definition of time? They might be hemming and hawing because it's a very foreign concept, even though it governs what we do on a day-to-day basis. So, what is time according to us physicists? Well, simply put, time is, wait for it, change. Whoa. That doesn't clarify anything. Well, let me give you a clarified definition. Time is the interval which change occurs. Got you there, right? No, you're right. It doesn't make any sense. Well, how about this? What if I were to ask you this question? How do you know that time has passed without the use of any tool, such as a watch or a sundial? Well, the answer to that question is, you know that time has passed if something changes. For us as human beings, we know that one day, one unit of time, a day, has passed if the sun rises and the sun sets, right? We know that's an entire day. Well, the sun has to rise again, right? But if you were to take a look outside, we know that time hasn't frozen or anything because things move, right? We see leaves rustle, you might see a car pass by, and those things can only occur because things are changing, and we call that frame of change, we call that time. Wow, that's pretty deep. I know. So let's take a look at this idea of time and how it applies to us in physics. We use time a lot. Now, in the equations, we represent time with the lowercase t, and that represents time. Now, please don't use a uppercase t because that actually does mean something else for us here in physics, lowercase t, and the units for time are lowercase s for seconds. Okay. Now, sometimes you might see minutes, sometimes you might see hours, sometimes you might see days, sometimes you might see years. Okay. But we should always be able to convert these units into the unit time. Now, just in case, I'll go over the most common conversions. We know that there are 60 seconds in 1 minute. We know that there are 60 minutes in 1 hour. We know that there are 24 hours in 1 day. Okay, and I think the one that you should memorize is this one over here. There are 3,600 seconds in 1 hour, and that's because sometimes you don't see seconds used as often as hours, especially when it comes to our next topic, speed and velocity. Okay, now I do want to go over a couple of things. In the definition, we say that time is change, and for us in physics, change also can be written as delta. Okay, if you remember from the previous video, delta is the final minus the initial. So technically, time in the equations should be written as delta t, but oftentimes you will see time not written as delta t, which is the final time minus the initial time, but regular as just t. And let me go into why. So whenever you are measuring the amount of time that has changed, usually, I would say most of the time, you do not start at any other time except for time of 0 seconds. You always start at 0 seconds. Okay. Our watches work that way. If we were to use a stopwatch, and it just kind of makes sense. And so if we were to use this equation, delta t is equal to tf minus t0, and our starting time is always 0 seconds, right? That's 0 seconds that numerically is 0 in an equation. It doesn't really do anything for us. And so we're just we're left with delta t is equal to tf, and to just simplify things, whenever you see time in a equation, you usually don't see delta t, but rather just the letter t, to denote that the starting time was at 0 seconds. Okay, so let's get that out of the way. Next, let's go into this idea of speed. Speed. Now, speed is one of those terminologies that we see in our day-to-day language, and you should be pretty familiar with speed. So if I were to ask you, what is the definition of speed? A very common answer that I get is how fast something moves. Okay, well, that doesn't really clarify anything to us, right? So if you were to think about it a little bit more, you could say how fast something goes, from one point to another. All right, so we're getting somewhere. Now, for us here in the physics world, this is a okay definition, but we can summarize this a little bit more cleaner. It is the total distance divided by the total elapsed time. Okay, and if you're thinking to yourself, Mr. Lee, this kind of looks like an equation. Well, you're right. Oftentimes in physics, the definition comes from the equation itself. So let's break this down. speed is just the distance divided by the total elapsed time. Okay. Now, if you remember from the previous unit, the distance displacement, we can now come up with the units for speed. So if you remember, the units for distance is meters, and I just told you that the units for time are seconds, and therefore that gives us the units for speed, which is meters per second. Some common units that you might see are kilometers or kilometers per hour. And here in the United States, we also see miles per hour, which can be written as mph, okay, which is just miles divided by the hour, but we don't use that. We always use meters per second or kilometers per hour because those are the SI units, and miles are not SI units. Okay, so a couple things that I want to go over. Speed is what we call a scalar, and a scalar gives us the magnitude. Now, the magnitude or a scalar, it does not care about direction. All right. So if you think about it, in your car, it tells you how fast you're going, but it doesn't tell you in what direction you're going, right? So for example, if you're going 50 miles per hour, like is that 50 miles per hour north, 50 miles per hour east? It doesn't matter to the car, okay? Because that's a scalar. Your speed or your speedometer only cares about how fast you're going, or the number, okay? No direction required. So magnitude is just the number. And because it doesn't care about direction, this scalar or this magnitude will always be a positive value. Because remember, negatives in terms of us in physics, it actually has a meaning, okay? And that meaning comes in the form of direction. All right, so that's speed. Let's take a look at velocity here. Velocity. Now, in our day-to-day language, people use velocity and speed interchangeably, but we can't do that in physics. So velocity is the displacement divided by the time of travel. All right, so right there, we can see that there's a big difference. Speed cares about distance. Velocity cares about displacement. That's huge. That is ginormous, and that tells us a lot about the speed or a velocity of a object. Let's go into the equation. The equation for velocity, lowercase v, is the displacement, which is delta x, divided by the time of travel, which is delta t. Okay, so sometimes you might see this written as delta x over t, and sometimes you may even see this broken down even more as just x over t. Now, just so you know, if you see it written as x over t, there's a couple liberties that we're taking here, and that is that the initial position is 0 meters, and our initial time is also 0 seconds. And so, just so that we're not taking liberties, we will use this version of the equation for velocity. All right. So let's dive into this a little bit more. Velocity is what we call a vector. Okay, and vector cares about direction. So vectors have both magnitude and direction. So if you see something written as like -10 meters per second, okay, we know that this is automatically a velocity, because that negative, it could mean a couple of things. It could mean something like it's going to the left, it's going down, it could be going south, or whatever that negative means, okay? But it's still moving, right? We're not moving backwards in time, but that negative is just a direction. So if I were to ask you, what is the speed of this object that is moving at -10 meters per second? You can't say that it's -10 meters per second, because that's the velocity. The speed is just a magnitude, which is 10 meters per second. All right, so let's do a different example here. Let's say that we have a bird, and that bird is traveling at, I don't know, 25 meters per second northwest. Okay, the direction will be northwest, and the magnitude will be 25 meters per second. So this is the total velocity of the bird, that entire thing. However, the speed would just be 25 meters per second. It does not care about direction. Okay. All right. Well, that's it for this video. In the next video, we'll go over a couple of more specifics, a couple of examples, and really to know how to differentiate between speed and velocity. I'll see you next time. Bye-bye.